This video series complements the scaling and cloud series we did a while back. In that series, what we did is we used the server scaling technologies provided by the cloud provider. That would be auto scaling for AWS, virtual machine scale sets in Azure, and managed instance groups to deploy a very simple Flask microservice, which has 4 endpoints on a server, and then the scaling mechanism um, kept the number of servers running, and if the CPU went above 60%, it would add units. If it was below 60%, it would remove units. So its replication unit was a VM, and so that's how that loose series worked. And so what we're going to do in this new series is we're going to take that same microservice, the code's identical, and containerize it using Docker. And then once we do that, we will deploy it using the simplest runtime for the environment, which does the scaling for you. It's based on requests, but you don't have to deploy any servers. It's another serverless type technology, and the replication for new units is no longer a VM, it's a Docker container. And so what we'll do in this series is first we're going to use a document database for microservice data storage. That's DynamoDB for AWS, Cosmos DB for Azure, and Firestore. It's the same one we've used in the previous video, so I won't cover too much about it. Then what we're going to do is we're going to build a Docker container for that microservice, and once we've built the Docker container, we're going to push it into the cloud registry provider. And so if in Amazon, you've got Elastic Container Registry. For Azure, you got Azure Container Registry, and then for Google, you got the Google Artifact Registry. And then what we're going to do is use that container that's in the appropriate repository for the cloud provider, and we're going to deploy that container using the simplest container runtimes offered by each provider. Now, these runtimes are relatively new. 2021 is when App Runner and Container Apps came out, and 2019 is when Google Cloud Run came out. Their Kubernetes offering predates these by a number of years. So it's like they came back and said, okay, let's provide a simple way of running containers. It's more like spinning up a VM with an AMI. It's very similar. You say, okay, spin up a container, and here's the container image, and you don't have to do as much as you have to do with Kubernetes. And so now this is sort of a journey to Kubernetes. This is sort of a baby step. I think if you're ever going to do a containerized application, you're going to end up with Kubernetes. But what this allows you to do is, get stuff in and out of the registry because it uses the same registry, and it allows you to do some simple prototyping and unit testings on your containers before you kind of move on to Kubernetes. So again, this is sort of a stepping stone Kubernetes. My plan is to do another video on this exact same scenario done in Kubernetes. So, at that point, we'll have this Flask microservices run on VMs, run as serverless cloud functions, that type of thing, running as a container with these simple runtimes, and then running as a container with Kubernetes. And I think that'll be it for these microservices. I think I've used them in a lot of places. Okay, so let's get into a description of the cloud technologies. First of all, let's talk about the container registry solutions. Now, there's a lot of information here, but the reality is that these container services they're pretty they work pretty much the same, and the reason for that is because Docker defined how a registry, the API and contract for how a registry works, and that was back in 2012, 2013. And so they have to implement that. So you're not going to see a lot of functional differences because they're just implementing something that somebody else defined. So they didn't put their secret sauce on it, and for the most part. There are some differences, particularly around pricing and that sort of things, and how region replication. But again, that's around the margins. For the most part, ECR for AWS, ACR for Azure, and GAR all kind of work the same, and They also all have scanning. They have different scanning tools that scans for vulnerabilities, but they're pretty much interchangeable in my mind. So let's to talk about the simplified container runtimes. And so App Runner, that was came out in 2021, and this allows you to just basically point to an ECR repository and have it run. Now it will scale. It's not by CPU, it's by incoming requests. It seems like the scaling rules for all of these are incoming requests, and they're geared towards, hey, you're implementing an API. You're not implementing a high CPU solution. You're implementing something that has has a high level of service coming in. It can't just slow down if it gets too many requests. So that's the how the scaling works for AWS App Runner. It's got TTL by default. It's very easy to set up, and it's um, a little bit more expensive, I believe. But here's what we will be implementing in the AWS version of this. Is we're going to deploy a registry. That's the first thing we do. And then after we deploy the registry, we build the container into the registry. So this is the RC1 of the Flask app. And once we've done that, we run another build where we instantiate the App Runner instance. It pulls the container, and then we define the roles. Actually, we define two sets of roles. The Flask app needs to be able to have a role that can interact with the app container or the registry, and then it also needs a role to interact with the DynamoDB. So it pulls the container, has roles, then it runs, then we've got HTTP endpoints, and we're good to go. So Azure Container Apps also very similar. It uses Kata, which is a Kubernetes thing for scaling. It does support a little bit more robust event scaling mechanisms. It also suggests to me that maybe Azure Container Apps on the back end is actually Kubernetes, since it's using Kubernetes scaling technologies. I don't know that for sure. That's just a guess. And so the diagram that we're going to build here is very similar. They're all very similar. We've got the container registry. Then we've got so we build that first. Then we build the Docker image, the Flask app RC1, push it in the registry. Then we create a container app, and that container app pulls the image, instantiates it, and interacts with the Cosmos DB. It's a little bit different as far as roles. We have to grant the registry a role, so the permission, so the Flask container connector. That same, we have to define a role on the database so that this allows it. So there's several roles that have to be set up for this to work. And we'll get to into the video. This one was a little more challenging with the roles because I had to create a managed identity, but we'll get to that in the actual video. The last one is Google Cloud Run. This is a run that's been around the longest. It's also very similar. It scales to based on load or requests, and it's also very similar. The first step is we built the artifact repository. We will push in Flask app RC1 into it. Then we spin up a Cloud Runner service. It pulls the instance, and then the table has to be it interacts with the table. Now the roles here are actually put on the project, so it's a little bit easier. The role to actually pull the container, and also the role to pull in that is all defined on the root level project. So that's the simplified runtimes. There's a comparison that we'll get into when I do the individual videos. They're very similar, probably more similar than the scaling one as far as the technologies. The names are different, but it works fundamentally the same. And so the last thing here is we'll do a quick look at the service endpoints. I do this always at the beginning. And so what I'm going to do is I ran the Google one, so I'm going to run validate here, and that should give me the good to go endpoint. And so I should go to here, and I can go into Postman, hit send, and you can see that works. Then I can say get candidates. I think you can have a bunch of stuff because Yeah, this has been hanging around for a while. So that's the second endpoint. And then for candidate, I'm going to say John. I'll say homie1. And so that's the third one. And then finally the post, I'm going to say Mike 20 Cloud. And that's the fourth one. So those are the four endpoints. And the one other thing is there's going to be a follow-up to this video. In those projects, there are I have set up GitHub Actions, and we're going to have a second project video series that's going to configure the GitHub Actions on all these.